Warm blood fragile foal syndrome is an autosomal recessive disorder caused by the mutation of the PLOD1 gene, also known as the LH1 gene. Normally, PLOD1 codes for the enzyme lysyl hydroxylase, which is used to convert lysine to hydroxylysine. Hydroxylysine is a binding factor in collagen, which is one of the key components used to build strong ligaments and tissues throughout the body.
However, when PLOD1 mutates, it is unable to code for the LH1 enzyme. With fewer functioning enzymes, less lysine is available to produce collagen, decreasing both the quality and the amount produced. This has devastating effects since this protein influences nearly every part of the body. For starters, it prevents cuts and tears in healthy skin by giving it its flexibility. Healthy collagen-filled skin is a lot like new rubber bands. Both are strong and pretty durable. However, foals with WFFS have old rubber band skin. It's much more brittle and doesn't stretch very far before it breaks. Collagen is crucial in ligaments as well, which can be compared to, work with me here, waistbands and underwear. Ligaments are elastic, so when they're stretched, the normal response would be for them to return to their previous length, as the BVD waistband does here. However, ligaments with too little collagen, like the older Hanes band, don't have the elasticity needed to go back and therefore stay stretched out. In other words, foals without the disorder have BVD ligaments. Their bodies have enough collagen to give their ligaments the strength needed to stabilize weight-bearing joints like the fetlock. For horses, it is especially important for these ligaments to be healthy and strong in competitions, ranch work, and even just walking to food and water. Unfortunately, offspring with WFFS have Hanes ligaments that stay stretched out. The collagen they produced is either not enough or too poor in quality. As a result, suspensory ligaments don't function properly and allow the fetlock to overextend. In April of 2018, Mary Nuttall wrote Breeders Beware of Fragile Foal Syndrome, in which she stated that foals with this disorder also develop tears in connective and organ tissues, in addition to having weak joints and fragile skin.
This applies to transmission population genetics across the United States. When a normal stud is bred to a carrier mare, there are two possible outcomes. In 50% of the progeny, only one mutated allele is inherited, while the other 50% will have two normal alleles. While these foals won't express any symptoms of the disorder, they still have the potential to pass the mutation on to their own offspring, increasing the alleles frequency in the population. On the other hand, if both the stud and the mare are carriers, the progeny will be 25% homozygous normal, 50% will be carriers, and 25% will be homozygous for the mutation. Because so many parts of the body rely on collagen for structural support, foals that inherit two muted alleles are either miscarried or won't survive more than a few hours after birth.
The article's author, Mary Nuttall, bred her mare with Sternlicht, a European stallion from Hilltop Farms, who was later found to be a carrier of warm blood fragile foal syndrome. The foal was born with WFFS and had to be euthanized shortly after birth. Hilltop Farms responded by pulling Sternlicht from circulation and announced they would move forward by testing all of their studs to prevent any further spread of the disorder into the warm blood population. Many in the industry support this action and propose that breeders across the world should be required to test their stock. Currently, in the United States does not have any laws mandating that farms inform the public about which sires have tested positive for carrying the mutated PLOD1 gene. Dead foals produce no profit for breeders, so there would be a significant incentive to minimize the number of potential cases of affected offspring. This would decrease the number of fatalities by ensuring carriers of the LH1 gene mutation would be removed from the breeding pool.